Good morning, everybody. This is a short video on guiding. The last couple of weeks we talked about links, characteristics of links, and now we're looking at guides. Just a reminder that guides allow you to move in a controlled manner. That's why here the words that are missing are control the motion. And without these guides, the objects would be useless and sometimes even dangerous. For example, like train tracks. The tracks are a vital component that guide the movement of a train. So let's look at a couple, well, actually three of them. The first one is a translational guidance. The missing word here is straight. So translation guidance ensures a part moves in a straight line or back and forth, whether it's horizontal or vertically, but there's no rotation here. It's really just straight forward. And I have the window as an example, but you can think of other ideas. We have the drawers. I have this box of cheese, and if you see, this has like a drawer type of thing, and the guide in here would be the box that allows the translational movement of the tray. Next is a rotational guidance, so ensures a circular motion of a moving part, and it's usually the axle that's in the center of the wheel or whatever gear, something like that, that is turning. Without the axle, the object would not be able to move in that specific manner. So in a bicycle, it's the middle screw, but you have here, like in these gears here, you have the center axle that allows the movement of rotation, you see? So if I take away the guide, this would be totally a useless piece, unable to spin. Next is the helical guidance, ensures the translational motion of a moving part while it rotates around the same axis. So it must be translating and rotating at the same time. And a helical path must be formed, or a spiral. You can even think of spiral moving. We have the C-clamp that you might have used in Tech Lab before, where you have you're going down and twisting at the same time. Okay? And the grooves allow that type of motion. The grooves, the kind of a diagonal grooves, allow this type of motion. I also have a wine bottle opener. You see that? And then inside also. So I would say the guiding control would be the base, the actual base of the wine bottle opener. And because of that, you're able to, it guides it. Without it, it would be a useless piece of metal. So this allows it to go down and spin at the same time. So here we can do the couple of examples together. Peanut butter jar. So if you think about it, when you do the twisting motion, and it has the same grooves that you have inside the C-clamp, that would be helical. The door handle is rotational. As you know, we twist, and there is an axle in the middle that allows the door to spin around it. The file cabinet drawer, so we have, if you see the groove on the side here, the drawer fits into it, and there's grooves inside the actual cabinet as well, so that it's able to move into it freely back and forth. And the last example is a laptop, which is rotational because it does a movement, if you look at my on the video, back and forth as such. It's true, it's not a complete circle, but it has to turn back and forth around an axle that you'd find. There's like a little piece down here, if you can see where the cursor is, here and on the other side, and that allows opening and closing. If you didn't have that, your laptop would fall apart. That's it for today. See you soon.